Hello guys, UC Studio here, and today we're going to be looking at another Blender tutorial. In this tutorial, we're going to be looking at fluid simulations in Blender. So let's get into the tutorial. I'm going to be explaining most of the things that you need to know about Blender's fluid simulations and how you can achieve all the different fluid simulations you might be needing to make in Blender. So let's get into the tutorial. So like you can see, we have our splash screen, which we're going to get rid of, and we're going to find the default cube. So here we are going to need to use the default cube, of course. So I'm gonna just come here to it and press G and move it alongside the Z axis up to somewhere there on that line. So yeah, so now we are going to add a press Shift A and add a sphere, and we're going to reduce it to a small size, which is 8, and we're going to also move it alongside the Z axis. Press G alongside the Z axis. So at this moment we save a file as something. I'm going to save it as tutorial. After saving it as tutorial, going to reduce it a little more by pressing S. With this sphere selected, now we are going to create our fluid simulation. So to create that, going to go to the physics tab, and I'm going to come here to fluid. Going to add it as a fluid, and when it asks me for the fluid type here, I'm going to fill in a flow. And we are not making a smoke today, we are dealing with liquids. So the flow behavior, we're going to select inflow, so after selecting all those, I'm going to come and select my cube, and that one is also going to be given a fluid physics, and the fluid type is going to be a domain. The domain type is going to be a liquid. Right now the resolution is at 32, and we're going to first try out with 32, resolution as 32. So come here and reduce the number of frames to about 100. I don't want my simulation to be that long, and I'm also going to reduce them here as well. So we have replay on, and we're going to check this resumable so that we can resume it as replay along. So I'm also going to come here in the liquid and check the mesh so that it can be able to create a mesh for us. Control S. So now if we play the simulation, it's going to be able to play. as you can see, that is the fluid that we are getting. That is using resolutions at 32, as you can see. So the time scale is still 1. So, but if you're creating something like water or honey or any other fluid that you might be creating, be it oil or something, fluids have different thicknesses and right about now, let's try to increase the resolution. So, gonna take it back to 0. I come here and multiply it by 2. And it becomes 64. Now it has become 64. So now let's try to play that one. As you can see, this is 64, and you can see right now that more fluid is being produced, and it's less thick compared to the previous one. So that one simply means that the more resolution value you put, the more fluid like the liquid is going to be, and the less thick it is going to be. So if you want to animate something that is more watery, you're gonna need to increase the resolution until everything looks fine to you. And if you want something less watery, more thick, like lava or something, you're gonna need something that is a resolution that is quite less. So it depends on the type of fluid that you might want to produce using this software. So now you know how the resolution works. So let's go to the time scale and see what changes with the different time scales. So I think for the time scale, let's just remain with this resolution 64. It's not too high. It is going to let us flow well with the tutorial. Let's go to the time scale, and you see how the time scale changes things here. I'll first pause and go back to frame 1 and increase the time scale to 1.5. So let's play that and see how it turns out. So yeah, as you can see, as we increase the time scale, things started to flow a little bit faster. So what does that mean? When you increase the time scale, you're going to have more fluid coming in. If you want fluids that are flowing very, very fast, you're gonna have to increase the time scale. If you want your fluids to move quite slow, you're gonna have to reduce the time scale. So it's really evident. If I bring the first one, the first clip that we made, and compare it with this one right now, you can see a very big difference in the amount of fluids that is accumulated with the 100 frames that we have. The higher time scale, then the more fluid. So according to the fluid you want to create, then you're going to need different time scales to use and with a resolution. So you combine all of those things together, then you're going to be able to get some amazingly well composed fluid simulations as you make your fluid simulations with the Blender. So let's go to another thing, and right now we are going to go back to our frame 1. So now let's try another thing. Alright, now so if I select the sphere here and I go to the initial velocity. So let's say I want the fluid to power more of this direction rather than directly powering it down. So if I want to make it flow in this direction, I'm gonna come here to the Y and give it an initial velocity of, like, let's say 2. Let's save it and let's play and see how it turns up. As you can see now, I've given it an initial velocity, so it's flowing to the Y direction. So you want to make a liquid flow at some direction, then you better give it a good initial velocity here, which you can set on different values. So as you can see now that I have my initial velocity on, and I've set it to the y-axis by 2 meters per second. Now, all these values here are really animatable, so you can really do amazing stuff with it when you're doing these fluid simulations. So you can make it rotate around by like making this a negative, then turns to a positive, then the fluid comes and rotates around as it pours. Very amazing, and those can be really good for animation. So now that you know that, let's bring in the other factor that you need to understand about the fluid simulation, which is the effector object. And now this is where we're going to powder the glass and make the liquid power into the glass. And now let's see how that one works. So let's go back to our frame 1. So now I'm going to add another cube by pressing Shift A and add a cube. Then we're going to need to scale it down to like that level and press G alongside the Z axis and place it somewhere there. And right now all we need to do is come to this modifier section and we add a subdivision surface modifier. I'm going to increase it to like 2 and go to the edit mode by pressing tab and make sure face selection is on and delete one of the faces. So now that I've deleted one of the faces, I'm gonna press Ctrl R and add edge loops, which I'm gonna put to around there. So I'm gonna come here to the X-ray and so that I can select these ones and press S to reduce the scale down to like that level is enough. Even here, S, there is enough. And I press S again. Yeah, that one looks fine to me. Then I can press Shift E and give it more crease this side. That one looks fine, and that one looks fine, and I press tab again. Now I increase on the viewport levels and apply it. Now we have the geometry. So I'm gonna come here to solidify modifier, give it some thickness. I think that 0.3 is enough, and then apply. So the geometry is applied there. So press Ctrl S to save, and now this is going to be the effector object. So now what I'm going to do is go back to the physics tab and select fluid, then fluid type to effector this time, and effector is going to be collision. Sometimes it can be the guide. Press Ctrl S. Now let's first go here and select this sphere, and now that we've selected the sphere, let's come and deactivate initial velocity because we want the fluid to really pour inside the glass, not outside. So let's uncheck it, and now if I play it, you can see that the fluid goes all the way through our effector object, and it's not supposed to go through the effector object. So if it does that and you've already activated the effector object, you might need to come here and you check it is planar, so that you avoid such problems in your fluid simulation. So if I play again when I've activated its planar, you can see that the fluid actually doesn't go through the glass, it goes into the glass. See how it is? It is actually gone into the glass. It's not outside of it. So yeah, we can bake this. Go to all and select is resumable. Then I click the bake all. Then it will bake for some time and we shall have our fluid running. Yeah, now it's done baking. And if I play the simulation, you can see how nicely it comes and fills up our glass. But let's say you want to animate it to stop and you want the fluid to stop at some point. So let me show you how to do that. So you're going to select the sphere, which is the flow object, and you're going to come here to the use flow, which is found in the physics tab, and it's already checked. So when it's checked, it means the flow object can release a fluid. If it's not checked, it means the flow object can't release a fluid. So its major essence is to control when to apply the fluid. So if you want it to stop, we're going to come to a good frame, like we have already baked 100 frames. So I'm going to come at around frame 80 and add a keyframe to it. Which is going to be added by coming to this dot here. That is always the animate property. So I'm going to click on it. So on clicking on it, I've already assigned a keyframe and it's already there and visible. Then I come to the 100 frame where I'm going to add another keyframe to animate the fluid not flowing. So I uncheck it and animate the property. Now we have a keyframe there too. So beyond frame 100, we're not going to have any fluid flowing there. We're again selecting the domain object, and we're going to come down here and increase the amount of frames that this domain object is going to flow for. So they're 100 now. I'm going to increase them to 150. Then after increasing them to 150, you can see that it is automatically giving us an option to resume the bake. So I'm going to come here to resume bake and click it to bake the rest of the simulation. That is why it's very important to always check the is resumable. So let's resume the bake. So now our bake is done. So let's play it and see if it stops when it reaches the 100th frame. And yeah, you can now see the fluid stopping. So let's just assign some quick materials and render our simulation to see what comes out.